Okay, our introduction to probability. The main thing we want to make sure that we emphasize is the general rounding rule. For probability, if we're going to use decimals, we want to go to 3 decimal places. Okay, so what is probability? Probability is the chance of an event occurring and it can be written as a decimal percent or a fraction. The result as an outcome, it's the result of a single trial of a probability experiment. Okay, the sample space is a list of all possible outcomes, of course, of a probability experiment. I'm just not going to write that part. So some examples. If we roll a single die, we could have 1, 2, 3, 4, basically the numbers on the die. 5, 6, if it's a true, false question. Then we have true or false, naturally. If it's a coin, we have heads or tails. 2 coins, you can have heads on the first, heads on the second, heads on the first, tails on the second. Oops, let's do this. You could have tails on the first, heads on the second, or you could have 2 tails. Rolling 2 die, or 2 dice, what would be the possible outcomes? You think of your first die, you can have 1, 2, 3, 4, 5, 6, or you can have on your second die 1, 2, 3, 4, 5, 6. So the first die would be 1, and the second die would be 1, 2, 3, 4, 5, 6, or you could have 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. You can have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Or you could have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. If you count that up, you would have 36 possible outcomes. The shortcut to that is 1 die, you have 6 possibilities. 2, you have 6 squared. So if I had 3 dice, I could have 216 possibilities. We can use a tree diagram. It's a way to count all the possibilities. So let's use a tree diagram to to the sample space for 3 children. So you could have child 1 be a girl or a boy. Child 2 would be a girl or a boy. So you could do the first one's a girl, the second one could be a girl, and the first one could be a girl, the second one be a boy. First one a boy, the second one a girl, first one a boy, second one a boy. And then child 3, same thing. You could have girl, 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 or girl, girl, boy. Girl, boy. So from the second child, you can always still have 2 possibilities. So the possible outcomes. You could have all girls. The first one be a girl, and the next 2 be boys. First one be a girl, the second one a boy, the third one a girl. Girl, boy, boy. You could have boy and 2 girls as your second and third. Boy, girl, boy. Boy, boy, girl. Or all boys. So you have 8 possibilities, which we had 2 original outcomes and then raised to the 3rd power because there's 3 times. A simple event is just an event with 1 outcome. Oops. So think of an example of rolling a die and getting a 3. Compound is an event with more than 1. Example could be rolling a die. Die is just a single and getting an even number. Right, so that could be 2, 4, or 6. Classical probability, noted as P of probability of the event, is the number of desired outcomes over the total number of possible. So, using our P of an event, that just means the probability of an event. So let's look at some rules. So, probability of an event equaling 0 means event cannot occur. 0% chance. Not likely. If it equals 1, it can certainly occur, or I should say is certain to occur. So it's 100%. Cannot exceed 1. And can't be negative. So probabilities must be between 0 and 1, or 0 and 1%. And the sum of all probabilities in a sample space must equal 1 or 100%. So are these probabilities possible? So that's between 0 and 1. That's between 0 and 1. This is negative, so no. This is greater than 1, so no. This is negative, so no. This is 0, so yes. This is 1, so yes. 30%, yes. Okay, so we do a single die. Probability can give 6. Well, 6 is only on the die once, but there are 6 possibilities. 1, 2, 3, 4, 5, 6. Okay, what about probability of 1 or 5? Okay, well, 1's on there one time, 5's on there one time, so that's 2 out of 6, which is 1/3. And we always do the most reduced form. An even number. Well, 2, 4, and 6 are both my even numbers, so that's 3 out of 6 total, or we have a 50% chance. What about greater than 4 and an even number? Okay, well, the only number greater than 4 that is even is a 6. There's only one of those out of 6 possibilities. 2 die. Remember, there's 36 possible outcomes, adding up to 8. So if you go back to your chart and look, the sum is 8. So where's the sum 8? Well, on this diagonal right here. How many is that? 1, 2, 3, 4, 5. Okay, so that would be 5 out of 36. We'll add up to 8 or 11. Well, we already know adding up to 8 is 5. How many add up to 11? Just 2 more. So that would be, sorry about all the moving around, 7. Doubles. Well, you can have double 1s, double 2s, doubles 3s, doubles 4s, doubles 5s, doubles 6. So that's 6 of them. And greater than 2. Well, greater than 2 is all of them, but what equals 2? And the only ones that equal 2 is double 1s. All right, so double 1s okay, and there's only one of those, so that means there's 35 that would be greater. So 35 out of 36. And this ends part 1.